Today, let's look for patterns when we multiply fractions. So what is the shaded area in this figure? Well, is the shaded area more or less than a fourth square unit? Well, when I look at this figure, I might divide it here in half. So I can see that if I look at this half and I divide it again, this would be the fourth. So I can tell that it is more than a fourth because half of that half is a fourth, and I can see that it's more than a fourth. So let's make an estimate. That might be too low, about right, and too high. So like we said, a fourth would be too low, which means that an eighth would be even smaller than that. So that would be too low. So let's do the one that's about right. Okay, so about right, I have divided this figure into 10 sections. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And out of those, I have 3 sections. So, about right might be 3/10. And too high, I've divided it into half. So, if I was to say that half was shaded, we know that's too high, because we know that it is less than a half is actually shaded. Okay, so we are going to complete this table. So let's look at our diagram here. We have 1, 2 shaded out of 1, 2, 3, 4, 5 sections of one of these 3 thirds. Here's a third, here is a third, and here is a third. So the whole is divided into 3 sections. Here's a third, here's a third, and here's a third. So out of that 1/3, I have 2/5 shaded. So 2/5 out of 1/3 gives me 2 times 1 is 2. 5 times 3 is 15. So the area of the shaded rectangle on the first diagram is 2/15. Okay, let's look at this next one. We have 1, 2, 3 shaded out of 4, 5 sections. And of course, the one whole is divided into 3 sections again. So we have 3/5 out of one of the thirds. So I have 3 times 1 is 3. 5 times 3 is 15. So the area of the shaded rectangle for figure 2 is 3/15. Okay, let's look at this one. I have 1, 2, 3, 4 shaded out of 5 of one of the third sections. So 4 times 1 is 4. 5 times 3, 15. So what patterns do we notice in this table here? Well, as you go down the column of diagrams, there's an additional shaded rectangle. Okay, so here we have 2/5, here we have 3/5, and here we have 4/5. So we're shading another each time. And in all of the diagrams, we see that we have 1/3 because each whole is divided into 3 sections. Okay, let's look at our problem here. Han wrote this equation to represent the area of the shaded rectangle. We're going to explain where you see the equation in the diagram. Okay, so on the top here, we have that this section is one whole, and then they had to put another whole here. Okay, let's talk about why they had to do that. So we have 1, 2, 3, 4, 5, 6 that are shaded, which represents our numerator. And then there are 5 total pieces in one whole. So that's our denominator. So remember, your denominator represents the total pieces in one cake. So you get to eat, or the amount that's shaded, is 6. So we're getting to eat more than one whole cake. That's why they have had to add this next whole on the bottom. Okay, so we've got 6 pieces out of 5 in one cake shaded, and there are 3 sections, and we're talking about one of the sections. So one section out of 3 sections. That's where your 1/3 comes from. So 6 times 1 is 6. 5 times 3 is your 15. Okay, so today we multiplied a unit fraction by a non-unit fraction. Kyron wrote the explanation. I think the area of the shaded rectangle is 6/30 because 6/10 of 1/3 of the whole thing is shaded. Well, what do you think of what he says? What do you think he means? Well, I think that he thinks the 2 squares, this square and this square, is really one rectangle. So he's seeing it as one rectangle instead of 2 rectangles. So that's where he's looking at it. So instead of looking at this one as having 15 and this one as having 15, he's looking at them all together as 30 total pieces in a cake and giving us 6 that are shaded. So what mistake did he make? Well, he's counting all the rows in the rectangle as the denominator instead of noticing that we have 2 separate rectangles here. So he says 6 out of 30 total pieces.